Okay, so we're going to start with the algebraic properties of equality. This is going to go, once we set up our ISNs and we're ready for it, this is going to go on page 29 in your ISNs. We're just going to write page 29 up here at the top because I didn't put a blank there. These are not new to you. These are something that you learned way early on when you started talking about how numbers act with each other, when you talked about also the commutative property, the associative property, the distributive property, all those things together. When you first learned that 3 plus 5 is the same as 5 plus 3, things like that. So like we're talking elementary school here. These are the basic rules that allow you to do what you do when you solve equations. And you probably didn't have to actually use these and say these when you were learning to solve equations, but this is why your teacher said so much. Whatever you do to one side, you have to do to the other. Whenever they said that, that's pretty much a property of equality. So we know for the addition property of equality, if A equals B, okay, we want to keep the fact that it's equal to be true, so you got to balance the equation. If I add C to the left side, what do I have to do to the right side? Add C, okay? So when you add C to both sides, or whatever it is, that's the addition property of equality. You're changing what each side looks like, but you're keeping the fact that they're equal to each other. Okay? So subtraction property of equality looks pretty much the same. If A equals B, then A minus C equals B minus what? C. There you go. Multiplication property, if A equals B, then A times C has to equal what? B times C. Division property, so if A equals B and C is not 0, then A over C equals B over C. See how easy that is? That's so whatever you do to one side, you do to the other. The next two are kind of sound similar to each other, but they're very different, and sometimes they get mixed up. So we've got the symmetric property of equality. So if A equals B, then B equals A. All right. Now that looks like a reflection, right? Like I just flipped it around, but it's kind of a, what am I trying to say? It's reflection symmetry is what it is. So it's the symmetric property of equality. The reflexive property, if you look in the mirror, if A looks in the mirror, he doesn't see B. He sees A, right? When you look in the mirror, you see yourself. So the reflexive property, like looking in a mirror, A equals A. And it may seem ridiculous that you have to have a rule that says that, but for congruence, we actually use that a lot. And again, you have to have a rule for absolutely everything. And there is one. You just have to be able to state what they are. All right, so then we have the transitive property. So if A equals B and B equals C, then A equals, what do you think? C. It's like cutting out the middleman, right? If Johnny is the same age as Joe and Joe is the same age as Sam, then Johnny's the same age as Sam, right? So this is pretty much cutting out the middleman there. And then the substitution property of equality, if A equals B, then B can be substituted for A in any equation. And we're actually going to use the substitution property of equality in a way that looks a little weird to you at first, probably, here in just a minute. But so this should be like a quick review of those properties. We're going to keep those out and keep them handy for the next part of what we're going to do. Okay, so this part's going on page 30 when we're done. We're going to look at algebraic proof. Okay, proof is something that is a big part of geometry. Geometry used to be pretty much all proofs, like all year long. That's kind of been taken out, but we still have to justify what we know and why we know it along the way. So we're going to start by doing some proofs with just with equations from algebra, the stuff that you're familiar with and should be able to do, and you can kind of see how proof works. There's different ways you can do proofs. These are two-column proofs. There's paragraph proofs and flowchart proofs and other ways of doing things, but the most organized, like left-brained way of doing it is two-column proofs, and it's really what makes the most sense for the algebra part of it. So you've got, with the proofs, you have something that is given to you and then something that you are trying to prove. So basically here, I've given you an equation and I've given you the answer. There you go, that's your answer. So if that's all you can do is just look at it and go, ooh, n equals -2. Yeah, again, not impressing anybody because that's not really even what we're looking for here. We're really looking for the in-between. Now, one thing I want to make sure that you understand before we start this is that when you do the algebraic proof, when you're told you have to do a proof, you have to show every single frustrating step. If you are just solving this problem because it's part of something else we're doing, you don't have to show every single step. Some of you may choose to. I always have students that choose to show a lot of steps, and that's fine because that's what works for them. Do you have to show some work? Yes. If you don't show any work at all, I'm not going to take it. If you can just look at it and tell me the answer, that's great. Still not impressing anybody, I'm not going to take it. But you don't always have to show that you added this to both sides and that sort of thing. So I don't want you to take away from this because I think sometimes people think that after we do this, that's what I'm expecting of you every single time you ever solve an equation, and absolutely not, because then it kind of gets to where it's a little bit of a waste of time. But this right here is definitely something that you have to show every single step. Okay, so just make sure you don't get those two confused. We're not doing algebraic proofs all year and with everything that we ever do. All right. So to start this, we've got statements on the left and reasons on the right. So your first statement is what's given to you in this case. What I'm trying to solve. So over here on the left, I'm going to write -5 equals 3n minus 4 plus 5. Now, are you capable of simplifying that a little bit before you write it down? Yes, but you don't do that, okay? Because you have to have a reason for why you do that. And I know that you're used to doing that when you write the stuff down or you're setting something up, that it's easy to combine some things and it just makes your life a little easier along the way. Don't do that. And you will hear me say over and over again when we're setting things up, first step, 0 work. That's important because the geometry behind a lot of what we do is over the second you set it up, and then the rest is algebra. So if while you set it up, you're combining things and changing something, you're not actually using those geometric rules. Plus, if you accidentally mess up, because have you ever added anything wrong? Yes, don't lie. You have. I do too. I probably did it today already. I don't know. But I mean, it happens, right? So if you mess that up, then the whole thing's wrong. Whereas if you set it up and all you did was like plug everything in and write it down, and then you used a geometric rule to get there, you've shown me that you understand the geometry and the new part of what we're doing. And then when you mess up in the algebra, that's a whole different situation. Does that make sense? That also helps you understand what is it that you really don't get. Do you not get the geometry or do you not get the algebra part of it? Okay, because that's important too. Sit up, please. Sorry, I don't know your names yet. Thank you. All right, so there's my first statement. So how did I know that that is what I'm trying to solve? How do you know that that's what we're supposed to do? Because they gave it to you, right? So it's given to you. So your reason is given. Although given is used as a reason, the word prove is never a reason. Okay? So that was given to me. So now I've got to solve this. It's a very easy one to solve. I know that. Okay? It's not that I think you need every single step to solve it, but you have to do every single step when you're doing the proof. All right? So the first thing, now there's different ways you could start these, right? And if we weren't working these together, you might go about it a little bit of a different way than maybe what I'll lead you through or what somebody else might do. And that's okay, because our proofs might look different. But, I'm going to kind of lead you through a couple of these in a specific way. So the first thing that most of us would probably do would be to, would you say, like, combine these? I mean, it's the easiest thing, right? So in step 2, I'm going to go ahead and combine those. That's going to give me -5 equals 3n, then what? Plus 1. Okay? So I want you to look at that little sheet of properties of equality. And what you're looking for is the property that allows you to go from this to this. All right, so look at them, think about what you think it might be. And when you're looking at something, you're trying to figure it out, process of elimination is a pretty good thing. I know it can't be this one, it can't be this one, that sort of thing, and kind of narrow it down if you need to. Anybody want to take a guess? What do you think? Is that on your yellow sheet? It has to be a property on that sheet. What property on that sheet? Combined like terms is not on there. Is that what you're doing? Okay, I heard addition and I heard subtraction. Could you kind of look at that as either way, right? Okay. But is it the subtraction property of equality or addition property of equality? Well, could it be? Why is it the addition property of equality? Look at the example for the addition property of equality. Does that follow this? Did we add the same thing to both sides of the equal sign? No, we did not. Did we add? Yes, or subtract, again, however you want to look at it. So yes, we did that operation, but that is not the addition property of equality or the subtraction property of equality, okay? So what I did, and yes, I did combine like terms, but that's not one of my choices. I took this right here, and I replaced it with this. What's that called? Substitution. Remember I said it's going to kind of look a little bit weird? The answer to this reason here is the substitution property of equality. Now we're going to abbreviate some. We're going to abbreviate prop with the equal sign for property of equality because it doesn't all fit, and that's fine. We abbreviate a lot in here. We'll actually abbreviate substitution here in just a minute too. I'm just not ready to do that yet. So might seem kind of weird that you're combining like terms, but you put substitution. But if you think about what's happening, this and this have the same value, and since you're replacing it, that's what you're doing. It's substitution. You with me? Okay. So now you got one of two options here. I know I have to get in by itself, so I could move the 1 or I could move the -5. My suggestion to you, even if you have super strong algebra skills, is that if you have something by itself on the side of an equal sign, don't move it. Okay? Can you move it legally? Yes. Most of the time when y'all move it, do you mess it up? Yes. Okay? Because a lot of times what happens is people move this over here, the equal signs disappear, and then you start making up your own math. I see it all the time. So just for this, just to be safe, I would not even move that. If I did move it, what ends up over here on the left-hand side? 0. You just got to make sure you never lose your equal sign. And some people are very sloppy with their work. Even if you're not showing 1,000 steps, when you rewrite stuff, make sure you don't lose your equal sign, things like that. Because that makes you miss super easy stuff. And more often than not, you're going to miss the easy stuff, not the hard stuff. And that's because you fly through it and you're not thinking about it. So I'm going to leave this here, right, just to be safe. So instead, I'm going to move the 1, which means I have to do what? I subtract. Okay, so here's where, again, you've got to show every single painful step because it's a proof. So I'm going to have -5 minus 1 equals 3n plus 1 minus 1. Now, because I subtracted 1 from both sides, that makes this the subtraction property of equality. And it's very important that we put the property of equality on there because there are also properties of congruence and properties of similarity, some of which are the same as the properties of equality, but not all of them translate to one or the other, so we have to make sure we're talking about which one. Everybody with me so far? Okay. So now I can clean this up a little bit. I can combine my like terms. That can't be my reason, but that's what I'm doing. And so -5 minus 1 is what? -6. That's equal to just 3n, right? The 1 goes away. That's the whole point, whole reason you do it. So what do you think your reason is here? Substitution. Now, I'm going to abbreviate it this time. Do you think I can abbreviate it just SUB period? No, because of subtraction, right? So I'm going to do SUB ST. And you don't have to abbreviate, but it's easier. There's a lot of writing in geometry. So when I say, hey, we're going to abbreviate this way, this way, and this way, you probably want to take me up on that. Okay. All right, so now we're here. So now I've still got to get in by itself. So what do I have to do now? Divide by 3. So this is going to be -6 divided by 3 equals 3n divided by 3. What do you think this reason is? Good. Division, property of equality. Abbreviations are fine as long as they make sense. By that I mean SUB period doesn't make sense because I don't know which one that is, right? DIV period is fine because nothing else would make sense right here. All right, so now at this step, if I were working this, or let me ask you this: when you're all is said and done, does your variable have to be on the left? No. Okay. Now, but if you look up at what you're told to prove, are you told to prove that n equals -2 or -2 equals n? N equals -2, so that makes a difference. My variable will always be on the left. Not because it has to be, and I'm not exactly sure why. I have a pretty good feeling that my teachers back in the day drilled it into our brains that your variable's on the left, because it's just out of habit. I don't even realize I do it. Like, I can't leave it on the right. It bothers me, and it's not just because little things like that bother me. I think that I had teachers that drilled that in my head. So if I was just working this and it wasn't a proof, my next step, I could have n on the left. That's totally fine. But because this is a proof, I can't do that. The only thing I can do is go ahead and clean this up. And so this would give me -2 equals n, right? And what's my reason for that? Substitution, property of equality. Some of this will seem very repetitive, okay? Don't think that that is a bad thing. Look at that as a good thing. It's repetitive. It could either be that, or there could be a different reason for every single thing, and we could have a list of 50 different reasons we have to use right now, right? Repetitive is really not that bad. Okay, so now, again, I'm still not done. Nobody told me to prove that. I'm supposed to prove that n equals -2. So it takes me one more step to get that n equals -2. What's my reason for that? Symmetric. Look at your examples. Remember, reflexive is like looking in the mirror. When you look in the mirror, you see yourself. You don't see somebody else. A doesn't see B. A sees A. So this is the symmetric property. Symmetric property of equality. Okay, everybody good? Way more steps than would be necessary, I know, for you to actually solve it. That's just the way proof goes. Because you have to be very specific about everything you know. Why? How do you know you can do that? What allows you to do that? And your reasons have to be official things. Right now, we're just looking at some properties. Any questions? We all good so far? All right, let's work through the next one together. All right, so I've got my given. I'm going to go ahead and write that down. 5x squared plus 19x minus 45 equals 5x times x plus 2. You just write it down exactly like you see it. Or if you're going to set up an equation when we're working through stuff and you know you're supposed to take these two things and set them equal to each other, that's all you do is literally take whatever it is and set it equal to each other. Even if you could combine stuff in your head before you did that. Then you move forward and you can skip steps all day long if it's not a proof. As long as you show me something and you're doing it right. What's my reason here? Given. Okay. All right, so I probably want to take care of this over here first. Would you agree with that? So, not that you have to, but do you ever take this and when you're trying to simplify that out, mess it up and not multiply by the second one? Yes, don't lie. You know you've all messed it up at least once, right? And it happens when it's easy and you're flying through it. I'm not saying you do it all the time, and I'm not saying you don't know what to do. I'm very confident that you know exactly how to do it correctly. But that stuff that you know exactly how to do correctly sometimes doesn't work out so well. If you really never mess it up that often, maybe like ever, maybe once, then you're good. If you kind of make that mistake a lot, then you might want to draw little arrows. Not all of you need to do that. You know if you need to do it or not, and if you need to do it, there's no shame in it. You do whatever you need to do so you don't mess things up, right? Although I have had students that do the little arrows and they still don't do it right. I don't really know how to help you there. That's just, again, you flying through it too quickly because it is easy. All right, so to move on then, I'm going to rewrite the left-hand side, so 5x squared, and I know that this blank is kind of short for this, kind of have to cram it in there. You could write it on, like you kind of double it in there if you needed to. Plus 19x minus 45 equals 5 what? X squared, then what? Plus 10x. Okay. Now I want you to think about what we just did. I multiplied 5x times x, right? But is this the multiplication property of equality? No, it's not. So there's a better answer than substitution, though. We did replace something that has the same value, right? But what is this actually called? I was careful not to actually say the name. Distributive, okay? And it's not the distributive property of equality because we didn't really do things to both sides. It's just the distributive property. And that's it. It's not on that list, but I know you know the distributive property, so I didn't worry about that one. We all good so far? All right, so this equation is different in many ways than the first one that we did. Since this has an x squared in it, it looks like this equation is what kind of equation? What's it called? Quadratic, okay? Looks like a quadratic. If you're going to solve a quadratic, in most of the ways to solve a quadratic, there's somewhere you don't have to, but what do you want to do to this first before you worry about anything else? Okay, simplify by what? Like by what? I got to combine them. What do I have to set this equal to? 0. Got to set it equal to 0 to solve for x, right? Again, there are ways to solve it without setting it equal to 0, but most of the ways y'all know and you're familiar with, you set it equal to 0. So to start by setting it equal to 0, I'm going to move things around. So I'm going to move the 5x squared, okay? So I'm going to subtract 5x squared from both sides. So this is going to give me 5x squared plus 19x minus 45 minus 5x squared. And here's where the one little time you might run out of room, but you can make it fit. Equals 5x squared plus 10x minus 5x squared. I have to kind of put mine down there. I write big. So a lot to write, but we can get it down there. So what's my reason for this? What is it? I heard it. You said that. Subtraction, what? Property of equality. Good. So it's the subtraction property of equality. So now, clean it up. Well, I've got 5x squared minus 5x squared, so those just go away. So I'm left with 19x minus 45 equals, well, there's 5x squared minus 5x squared, so I just left with 10x. So although it looks like a quadratic, is it? No. So although it was kind of big and scary and intimidating, it's really not that bad in the end, right? What's my reason? What allows me to go from 3 to 4? Substitution. Good. So substitution, property of equality. Now again, I've got one thing by itself over here, so I'm not going to move it. I don't want to mess anything up. So I'm going to move this. Good, minus 19x. So I get 19x minus 45 minus 19x equals 10x minus 19x. And my reason for that? Substitution. Oh, wait, I'm sorry, no. Subtraction, sorry, thank you. Subtraction, property of equality. I was just seeing if you're paying attention. I'm almost always lying when I say that. All right, so I've subtracted 19x from both sides, so now I clean it up a little bit. These two are going to cancel out, so I get negative 45 equals what? Negative 9x, good. And so substitution. And for a lot of these, you may feel like every other one is substitution, and it very well may be, because you do something, you clean it up. You do something, you clean it up. And again, repetitive is not bad when it's easy. All right, so now I have to do what? Divide. So I'm going to get negative 45 divided by negative 9 equals negative 9x divided by negative 9. Good. Division, property of equality. Then substitution. So what's negative 45 divided by negative 9? 5. That's equal to x. So that is your substitution. Property of equality. Am I done? No. Good. So now I've got x equals 5, and that's the symmetric property of equality. So all of those these are all the actual rules that allow you to do what you've been doing, right? Because there's a purpose behind each of it. Now there's an extra blank. That's okay. I put blanks on there just to make sure that you had plenty. Sometimes there might be extra. Sometimes you might need one more than what you have, because if you approach it a different way, it may take you one more step or one less step than what was going on in my brain, and that's okay. That's one thing that makes grading geometry stuff kind of a nightmare a lot of times, is that there is a lot of times more than one answer or more than one way to do things, and one's not necessarily better than the other. And so our answers and our process might look different, but it doesn't mean that either one of us is wrong, okay? You can combine steps. I kind of hesitate. I caution you against it, especially when there's so much to write and you've got to rewrite stuff. But what we could have done, because I always get this question, so I just want to throw this out there. Like we did subtraction, and then like the next thing we did was subtraction. So really right here, where I subtracted 5x squared from both sides, I could have also subtracted 19x from both sides at the same time, because they have the same reason. Does that make sense? But here I couldn't have subtracted and divided at the same time, because that would give me two different reasons. So I know a lot of times when you're solving easy things, you might think, I'm going to add this to this side and subtract this over here. And again, on a normal day where you're just solving things, that's fine. But I couldn't do this here because adding and subtracting are two different properties. You with me? That makes sense? Okay. All right. Any questions so far? Good? All right. I'm going to give you just a little bit of time to work the next one on your own, because I don't want to make sure I have time to talk through it all. So I'm going to give you this. I'm going to give you time to write it down. I know it's kind of long. Can make it fit. And there are one of two ways that you could start. You could either start by combining these, or you could start by distributing. It wouldn't matter, and ours might be different, but what I've found, especially with this one, it looks so long and weird, is that once you start off, if I let you start and then I come back and talk about it and you started differently than I did, you freak out a little bit and you feel like you have to erase it and change it. You don't have to, but let's just go ahead and as a group, so I can let you get started because I think you get a little ways. Let's just decide, do we want to distribute first or do you want to combine these first? Okay, so then what I want you to do is your distributive first, and then go ahead. Well, I'm going to pass out the homework so it's sitting there while you get that started, and then we'll walk through it together. So I've got 10 times x minus 3 minus negative 9x minus 4 equals x minus 5 plus 3. So that is my given. So we decided that we were going to go ahead and distribute first. So I'm going to get 10x, then what? Minus 30, then what? Plus 9x, very good, plus 4 equals x minus 5 plus 3. Like I can't do anything with that yet, even though it's easy and we're capable of it. So my reason here is what? Distributive property. Okay. Now, this is actually the best decision, and you don't always know which is the best decision when you start, right? But this is kind of the best one to do, because if we had combined these first and then distributed, then we have to combine again. Because we distributed first, we can do all our combining in one step. Does that make sense? And you don't always know that until it happens, but that was a good decision to make. So let's go to step 3 then. So I'll go ahead and combine my like terms. So on the left, that the 10x and the 9x means 19x. Negative 30 and positive 4, negative 26. That's equal to x, what? Minus 2. All right, so my reason is substitution, property of equality. All right. So then I've got this, and this is one of those cases where if I were working it and it wasn't a proof, I would subtract x over here and add the 26, but I can't do that because those are two different properties, so I can't do them at the same time here. So do you add the 26 to 2? You want to do that first? So we'll do 19x minus 26 plus 26 equals x minus 2 plus 26. Okay, so that is the addition property of equality. It's the first time we had to write that one, but hopefully it should make sense, right? So then I can clean it up a little bit. And on the left, I'm left with 19x. It's equal to x plus 24. That's your substitution property of equality. Then I've got to subtract the x, right? So 19x minus x plus 24. Yes, and I just heard somebody say x minus x plus 24, which is fine. You don't have to put that at the end. You can put it next to whatever it's going to cancel out with. That is totally okay. Whatever order is absolutely fine. And so that makes this the subtraction property of equality. So then I have 18x equals 24. Substitution again. This is where we become thankful we can abbreviate some things. Lots of writing in geometry. Then we have to divide, right? So 18x over 18 equals 24 over 18. That is your division property of equality. So then, would a decimal be okay here? No. Would a mixed number be okay here? No. And not just because you already have what x is up there. In this case right here, I'm going to make you believers. That is like always my first goal of the year. I'm going to make you believers that fractions are way better than decimals ever will be. Okay, because first of all, this isn't going to divide evenly. Not only that, but it would give you a repeating number, which you can't write as a decimal. The whole little put in a line over it, yeah, no, that goes in the trash can. Mixed numbers go in the trash can. You use them for cooking, and that's it. okay? They may be given to you, but then you quickly put them into improper fractions. Improper fractions are the way to go. First of all, they're easier. It takes less work. You just stop. You got to learn to stop. And plus, if you ever needed to plug it back into something, you'd have to make it back into a mixed number anyway, so you're doing too much. So basically what happens here is that these cancel out, and then if you know it doesn't divide evenly, all you're really doing is reducing the fraction. Now, it says we're supposed to prove that, what, x equals 4/3? You can't just assume that that's 4/3, because if you did something wrong, then it's not really 4/3. But is this 4/3? Yes, they're both divisible by 6. So you get x equals 4/3, not 1 1/3, not 1.3 with a line over it. Oh my gosh, no. And my reason is substitution, property of equality. Now, do I need to use the symmetric property and flip it around? No, don't make that the last step every time. I see people do that too. You don't flip it around at the end just to flip it around. You flip it around only if you have to. Does that make sense? Any questions? All right, so these have ISN pages on them. Don't glue anything in yet. All right, in a couple days we'll set up our ISNs and it'll be good. But don't lose them. Your homework is stacked on your table. I always come around and stack the homework. I put it on the table and I pass it out. And then people leave and leave homework here. Don't be those people.